Throughout time, scientists have managed to uncover about 6,000 early human fossils, ranging from skulls to teeth. For some of these fossils, it was a breeze. Researchers could instantly identify them as belonging to, say, the Neanderthals. However, when it came to others, things got a bit trickier. Some fossils just didn't fit into any existing categories. So, what categories of prehistoric humans do we actually know about? Well, up until recently, we recognized 8 different species of early humans. One of these is Homo habilis, which means handyman. You'll recall that Homo is Latin for human. They resembled regular primates, but were pivotal in our evolution. They were the first to create stone tools, which significantly aided their daily activities, such as butchering. Next up, we have Homo rudolfensis. These guys were larger than Homo habilis and boasted bigger brains, but they were still quite distant from modern humans. For example, even though the neurological structure of their brains was becoming more complex, they were probably not capable of using any form of actual spoken language. Then came Homo erectus, the first to walk upright, followed by Homo antecessor, which is considered the last common ancestor of modern humans and Neanderthals, along with a host of other Homo species. Meanwhile, we're still piecing together the story of the enigmatic Denisovans. Our knowledge of Homo naledi is pretty limited too, since it was only discovered in 2013, and it is species number 8. Interestingly, Naledi means star in the Sotho language because they were found in a cave called Rising Star. Scientists were taken aback by them. Everything suggested they were around 2 million years old. But after closer examination and some tests, it turns out that the Naledi species is much younger, between 236 and 335,000 years old. Their hands were adapted to making tools, yet no tools have been found nearby. Long story short, they're a puzzling species, and there's still so much more to learn about them. So even though today we have only one human species on our planet, Homo sapiens, we continue to discover ancient species that are long gone. Now you might wonder why researchers study these extinct species. The truth is, they need this knowledge to piece together the intricate narrative of our prehistoric past. In 2024, a significant discovery emerged, the 9th human species, named Homo giluensis, which translates to large-headed. Researchers suggest that this species hunted wild horses, crafted stone tools, and processed animal hides to survive harsh winters. A researcher from the University of Hawaii noted that the discovery of this potential new species came about while his team was developing a novel method for classifying fossil evidence. Interestingly, one potential representative of Homo giluensis isn't entirely new to science. The Denisovans, first identified in 2010 through DNA analysis of a finger bone found in Siberia, have yet to be classified as a distinct species. Some scientists propose that they may actually belong to this newly identified group. These big-headed individuals could help shed light on the long-standing mysteries surrounding these hominin fossils, which have puzzled researchers due to their mixed characteristics of Homo erectus and Homo sapiens. You see, sometimes it's tough to call a spade when you don't even know what a spade looks like. You get the idea? Many unsolved mysteries linger, simply because scientists haven't had this crucial, big-headed piece of the puzzle. So theoretically, we modern humans could also be considered a bit of Homo giluensis. You don't believe me? Well, watch this. We need to consider 2 key facts for this equation. First, there are the Denisovans, a group we might refer to as Homo giluensis from a scientific perspective. Yeah, this is just a theory proposed by some researchers, but let's roll with it for now and pretend it's a fact. Second, it's important to know that the Denisovans interbred with the ancestors of modern-day Melanesians. These folks inhabit areas ranging from New Guinea to the Fiji Islands and carry between 4 and 6% Denisovan DNA. Now, you might not personally have those genes, unless you've been tested, of course, but the key takeaway here is that there are modern humans today who share genetic links with the Denisovans, or Homo giluensis, or big heads if you prefer. Now, that all sounds pretty plausible, Let's unpack step by step how it happened. Researchers have uncovered this type of ancient human, known as the Denisovans, based on skeletal remains found in Siberia. These ancient humans coexisted and interbred with modern humans, adding yet another layer to our understanding of human evolution. Named after the Siberian caves where their fossils were discovered, the Denisovans are believed to have roamed widely across Eurasia. Evidence indicates that the Denisovans lived alongside Neanderthals and interacted with early Homo sapiens, possibly around 50,000 years ago. A team of scientists successfully sequenced a complete genome from these ancient hominins using nuclear DNA extracted from a finger bone. This discovery reveals that at least 4 distinct human groups existed during the time when anatomically modern humans began migrating out of Africa. Alongside modern humans and Neanderthals, we now have to consider the Denisovans and another small human species from Indonesia, often referred to as the Hobbit, when discussing our evolutionary history. One intriguing question that arises is why Denisovan genes are predominantly found in modern Melanesians, yet absent from other Eurasian populations. Remember that 4 to 6%? One hypothesis suggests that interactions between the Denisovans and early modern humans were limited and brief, especially as humans migrated throughout Southeast Asia into Melanesia. Scientists speculate that only a small number of the Denisovans may have interbred with a larger group of modern humans. This could explain how the Denisovan genes made their way into the gene pool despite the likelihood of infrequent encounters. Anyway, the more scientists dig into our past, the more fascinating things they uncover about our ancestors. Take Neanderthals, for example. Did you know these guys were responsible for creating the very first piece of art ever? I had no idea. But a 2018 study of ancient cave art in Spain revealed what are now considered the oldest known artistic creations. We used to think Neanderthals lacked the cognitive skills needed for art, but it turns out they were actual art pioneers. Not only did they create art, but they also seem to have invented hashtags thousands of years before Chris Messina did it in 2007. Right, I'm kidding, but you'll soon get why I mention hashtags. The artworks found in several caves in Spain include simple hand stencils, a ladder-like drawing, and various other markings. Until recently, these prehistoric pieces were believed to have been made by early humans. But new testing methods suggest they're much older than we thought. Above all, the earliest recognized Neanderthal artwork, which looks like a hashtag, was discovered in Gibraltar back in 2014. To determine the age of these artworks, scientists employed advanced dating techniques using eHarmony and Match.com. Oops, wait a minute, wrong dating techniques. They actually used uranium and thorium radioisotopes instead of the traditional carbon dating. Once the necessary tests were completed, they confirmed the art was approximately 65,000 years old, 15,000 years older than the previously oldest known art from Indonesia. At that time, the only species around were Neanderthals, so it's safe to say they were behind these creations. Modern humans didn't arrive in Spain until about 20,000 years later. Hey, it was a long commute. That rules them out as the hashtag creators. The hand stencil was likely created intentionally, with the artist preparing the pigment and applying it over their hand. Plus, the caves also contain a collection of painted seashells that are an astonishing 115,000 years old. Some of these shells have been drilled, suggesting they might have been used as jewelry. Some specialists argue that the fact Neanderthals created art hints that they might have also had some form of spoken language. So maybe it's time we fully embrace Neanderthals as part of our lineage. They're humans too, just a different branch of our family tree. While these findings are intriguing, some experts remain skeptical about the new dating methods, claiming they're not entirely convinced. Hey, what do you think? Share your thoughts in the comments. There's an amazing place in Ethiopia, East Africa, called Hadar. This place is a treasure trove. We found tons of old animal fossils there. And among those remnants, we discovered something very special. the fossils of a creature called Australopithecus afarensis. One of these guys was found almost complete. You might know it today by the name Lucy, after a famous song by the Beatles. Lucy was a small lady, only about as tall as a kitchen counter. She lived 3.2 million years ago and became a huge celebrity when we found her in 1974. She helped us learn more about our early ancestors, creatures called Australopithecines. Around 10 to 12 million years ago, there was a group of animals that broke into two branches. One of the branches led to modern apes, while the other led to humans. This separation happened because one group decided to stay in trees and became what we now call gorillas, chimpanzees, and orangutans. They moved around using all four limbs and lived in forests. But the other group decided to live on the ground and try walking on two legs. Because of that, their brains started getting bigger over time. And over millions of years, they became bald monkeys who watch videos on YouTube. Yeah, you know who you are. Lucy, like other Australopiths, was a bit different from us. She still looked like an ape and lived during a transitional stage. She could walk on two legs, but didn't do it all the time. Sometimes she climbed trees, just like a monkey. She and her buddies were the first step in human evolution. Then came a new branch of evolution, Homo habilis, or handyman. They were the first members of the Homo genus because they were the ones to start developing stone tools and first show human creativity. They probably used these tools for scavenging and processing food. We found the first clues about them back in the 1960s. They walked around East Africa about 3 million years ago. They were pretty small, about 4 feet 7 inches tall. They didn't climb trees anymore and mostly walked on the ground. Their skull shape already resembled ours, unlike the more pear-shaped heads of Australopiths. That's because they had larger brains. After them, we had Homo erectus, the upright man. They lived about 2 million to 70,000 years ago. The name hints that this was the first hominin species that walked on two legs almost all the time. They were also the first to migrate out of Africa, spreading to Asia and Europe. And here, we had the real breakthrough. Representatives of Homo erectus had even larger brains and learned to make more creative and advanced tools. They created the first choppers, cleavers, and hammers, and used flakes as scrapers and knives. They probably used a lot of things – wood, bark, and even grass to make the first strings and ropes. With all that, they learned how to hunt large animals and probably hunted together a lot. They were also the first ones to start using fire, which changed our history forever. Over time, more Homo species emerged, including the famous Neanderthals. They're known for their European roots. They split from our common ancestor around 400,000 years ago. Now, even though we share one common ancestor, we didn't evolve from Neanderthals. They were a separate branch. All Neanderthals went extinct, but our evolutionary branch coexisted with them a long time ago. Neanderthals were resourceful, hunting both land and sea creatures. They left behind thousands of stone tools and even decorated caves with paintings. They had their own ceremonies, too. They started to bury those who passed away. They probably noticed that leaving them in the wild leads to spreading diseases and attracting scavengers. But they also showed care and love in their burial rituals. Then it was time for archaic Homo sapiens. They lived around 500,000 to 200,000 years ago, emerging in Africa and Europe. This was the last leg between our ancestors and our modern species, Homo sapiens. The brain just kept getting bigger. They started to show more complex behaviors, not only burial and interesting stone tools, but also smart hunting strategies and planning for the future. They probably had a diverse diet that included both hunting and gathering. And finally, we reached the anatomically modern Homo sapiens. They emerged around 200,000 years ago in Africa. They had a similar skeletal structure and brain size to modern humans, and their behavior was pretty close to ours. They had complex social structures, started thinking in symbols, and so on. They migrated out of Africa around 60,000 years ago, spreading across the globe and eventually replacing other hominin species, such as Neanderthals. They started to create their first languages and form their first words. The first words were probably very simple, like "ah," to call someone, and ma for babies. After evolving into our final stage, we started advancing in our cultural and technological development. This development became very rapid over the last 200,000 years. About 12,000 years ago, the Neolithic period, also known as the New Stone Age, began. It marked the end of the glacial period. Humans started living in settled villages instead of constantly moving around. This change was brought about by the advent of agriculture, which allowed people to grow crops and raise animals like goats and sheep. Early humans started to domesticate animals, such as sheepdogs, for herding. We also started making the first art, leaving famous drawings in caves, handprints, animals, mostly cows, hunting, and many others. We even created the first currency. We began using clay tokens for transactions. This marked the beginning of commerce and the use of money. And finally, we started writing. And now the events could be recorded and passed down through written records. This is when history officially began. From that point on, we saw the development of agriculture, the rise of complex societies, the invention of writing and the wheel, and the emergence of civilizations. Our tools became more and more sophisticated, languages appeared, leading to the diverse cultures and societies seen today. So, why have we stopped evolving? The truth is, we haven't. Human evolution is an ongoing process, although it's not as dramatic as it used to be. We adapt to different environments, have different skin tones, appearances, body sizes, and genetic mutations that have influenced traits like lactose intolerance or resistance to certain diseases. But the world we live in today is very different from the one our ancestors inhabited. We don't suffer as much because we've developed technology, culture, and social systems. Thanks to this, evolution slowed down, seeing that we're doing okay as we are now. What we started experiencing is cultural evolution rather than a physical one. Plus, 200,000 years is a pretty short time period, considering the time span of the universe or even of our Earth. We should see what happens to us in hundreds of thousands of years. I won't be around then, but there are some theories about that. There's a big idea that, in the future, humans and machines might merge into one super being. We call it technological singularity, a state where we humans lead our technologies to the point where we won't be able to control their development anymore. For example, if AI gets so advanced, it will change everything about how we live. Despite the current rise of AI, we shouldn't be too worried about it taking over the world, at least not in the next few decades. All we've developed now is weak artificial intelligence, little simulations. They might look scary to those who don't know much about AI, but the truth is, they have yet far to go before they reach the grand complexity of the human brain, not to mention consciousness. However, many people believe it's only a matter of time before AI reaches this level of intelligence, and then our world might change forever. There are other possibilities too. For example, one day we might reach a level where we merge with machines and learn to upload our consciousness in the cloud. In that case, we might become a hive mind, taking over the internet using our brains, becoming one giant consciousness. No matter what happens in the future, one thing's certain: technology is changing fast, and it's going to affect all of us sooner or later.
Imagine that one day, poof, all the big, furry, and feathered creatures just vanish into thin air. Humans disappear as well, and now there's nothing left but microbes. What would happen to Earth? How long would it take for complex creatures to appear again? And what would they be like? Alright, welcome to the microbial world. Microbes are the tiniest building blocks of life, so small you can't even see them without a microscope. In this amazing world, there are three main groups of microbes: bacteria, archaea, and the single-celled organisms. Bacteria are everywhere, from the air you breathe to the food you eat. Some bacteria are good buddies, helping us digest our food, and even making yogurt taste yummy. But some of them can be mischievous and cause infections. Archaea are the tough explorers of our microscopic universe. Archaea are the daredevils of microbes, and they showed us that life can survive in the craziest conditions. For example, they can thrive in super hot springs, even in incredibly scorching temperatures. Some of them are even capable of living in volcanoes. They also feel pretty fine in the freezing cold. Certain bacteria can get busy even in icy places like the Arctic and Antarctica. There, they help break down things like old plants and animals that got frozen in time. They work as nature's cleanup crew, turning leftovers into useful bits. Or imagine the darkest depths of the ocean where sunlight can't reach. And who do we meet down there? Microbes again, who make food from all the weird chemicals in the water. And of course, they also live inside you. You're a walking microbe party. Your gut alone is a cozy home to trillions of bacteria that help you digest food and stay healthy. And finally, the single-celled organisms. They can be plant-like, making their own food through photosynthesis, or animal-like, hunting for their next tiny meal. Some single-celled organisms can even team up to form colonies that work together and build complex structures. All these microbes are the foundation of life. At first, there were nothing but microbes on Earth. They were just hanging out and enjoying the simple life. But time kept ticking, and the more years passed, the more they evolved. They changed a little, sometimes acquiring some special abilities and passing these abilities on to their children. Generations come and go, and those changes keep adding up. Microbes became more and more complex. And after billions of years and trillions of changes, they become something as amazing as the animals, plants, and people we see on Earth today. It was a very long and tedious process, so let's try to repeat it now. Like, what if all living organisms on our modern Earth, except for the first microbes, would disappear? Without the hustle and bustle of life, the world would become eerily quiet. Streets that were once filled with people and animals would now be empty and peaceful. Buildings and cities would stand alone like silent monuments to the vanished world. First, we would have a huge disruption of food chains. Without plants, herbivores, and carnivores, the intricate food chains and webs that sustain life would simply collapse. Our world wouldn't be as wild and vibrant. The tiny microbes are cool, but they can't recreate the same big, bustling party that we all love. Also, remember how we mentioned that microbes often eat the leftovers of animals and other organisms? Just like when you eat cake and turn it into energy, they turn these bits into nutrients that the Earth loves. But now, without the big animals and plants, there wouldn't be as much leftover cake. The microbes would still work hard, but their evolution would be really slowed down. Now, you might think that without plants, we wouldn't have any more oxygen. But this isn't entirely true. In fact, trees produce only about 20 to 30% of the oxygen on Earth. So who really helps us breathe? Plankton from SpongeBob. But seriously, ocean plankton, especially phytoplankton, which is responsible for around 80% of Earth's oxygen production. Phytoplankton are considered microorganisms. They're tiny, single-celled or colonial organisms that float around in the oceans, harnessing sunlight. So, if all land plants and animals disappeared, oceanic plankton would still continue to produce oxygen in the oceans through photosynthesis. They would become even more essential for maintaining a breathable atmosphere. Although now these guys would face some big challenges. You see, big animals like whales and fish usually provide nutrients to the ocean. These nutrients are plant food that phytoplankton need to grow and thrive. Without the big animals, there might be fewer of these special nutrients around. The phytoplankton might not grow as well. And since these guys act as the bottom of the ocean food chain, that could have a domino effect on the whole ocean food web. And also, with fewer plants, there's less oxygen being made, and carbon dioxide starts to stick around more. The balance of gases in the air would change a bit, and when the balance tips, it can affect the weather. The Earth's temperature and the way wind moves would change too. Plus, too much carbon dioxide can make the air feel a bit stuffy. Next, animals like moles, ants, and worms as nature's engineers. They're digging tunnels, burrows, and homes in the ground. When these animals dig and move around, they're actually helping the soil. They mix it up and create pathways for air and water to travel through. It's like they're giving the soil a good shake to keep it healthy. So without the animal engineers, the soil might get a bit packed and tight. Water from rain wouldn't be able to seep in as easily. When they're gone, the nutrients aren't getting spread around as much, and the soil might miss its tasty treats. So the whole ecosystem underground could become less cozy and more cramped. But the most interesting question is, what would happen to all our human artifacts? People disappeared, but their builds remained. Let's look at how this could affect the development of microbes on Earth. Our human-made things need proper care. So, if there were no more people around, all these things would be destroyed very fast. Microbes can grow on surfaces, and over time, they would start to cover buildings, streets, and structures. It might not be visible right away, but given enough time, you'd see a thin layer of microbial growth. Nature is a powerful thing. Buildings that were once shielded by human maintenance would now be exposed to the elements. Wind, rain, sun, and snow would all destroy and break down everything we've ever created. And some places on Earth have really tough weather, super hot summers, freezing winters, or crazy storms. In these areas, buildings and cities might even get sadder faster. Microbes would contribute to this too, as some of them produce acids that can break down materials. Slowly, cracks might appear, and materials like concrete and wood might weaken. Humans overestimate their power when they call themselves kings of nature. If we disappeared, in just a couple of thousand years, there would be almost no traces of human civilization left. It would be like we never even existed. But in any case, this event would offer an exciting opportunity for microbes to evolve in a completely new way. With the spotlight all to themselves, they're free to explore and adapt to their surroundings. Some places might become more challenging, while others might become easier to conquer. Microbes reproduce quickly, sometimes in just a matter of minutes. This rapid evolution could lead to a burst of new microbial species. Could microbes rehabitate the planet? Absolutely. Over time, new species of animals and plants would begin to appear. Like the butterfly effect, any small changes would have led to completely new types of life, and perhaps to new types of humans. In any case, these rapidly evolving microbes could reshape the way ecosystems work. They'd interact with each other in new ways, creating intricate relationships and cycles. The balance of life on Earth might be very different from what we know today. What would it look like? Let's leave that to your imagination.
If you've ever hit your toe on a corner and felt that sharp pain, you know what I mean by why we have such delicate feet. Our feet are super sensitive. They're covered with this special hairless skin full of nerve endings. That's why it hurts so bad when we get a foot injury. Yet they aren't as delicate as we think. It's incredible how our feet are put together. They consist of 26 bones, 33 joints, and over 100 muscles, tendons, and ligaments. These are working together like a machine to let us move around. When we run, our feet work like springs. They must handle up to 7 times our body weight every time they hit the ground. Thanks to the clever arrangement of ligaments, tendons, and muscles, our feet store and return much of that force to the ground. By the way, they can also give us hints about our overall health. And every pair of feet is unique. No two pairs are exactly the same. They come in different sizes, shapes, flexibility, strength, and walking patterns. It's like our feet have their own personalities. But how have our feet come to this point? Researchers have been trying to figure out when and how early humans started walking upright. Well, they've been looking at feet, toes to be exact. Bipedalism, which means walking on 2 legs, was a major step in human evolution. It influenced a bunch of other changes in our lineage, like how we behave socially and develop our material culture. So, these scientists have been digging into the details of foot evolution to piece together the story of our species. The team has been checking out these special joints called metatarsophalangeal joints, which are placed between the long bones of the foot and the toe bones. In 2015, they found that, unlike in other primates, this type of joint in humans faces upwards, allowing us to extend it, which is perfect for walking on two legs. But apes and other primates have downward-facing joints, giving their feet a hand-like grasp. In their latest study, the researchers looked at fossils of primates and hominins, a human group, to see when this upward-facing joint first appeared. It turned out it had shown up about 4.4 million years ago in the lateral toes closest to the outside edge of the foot. Yet the big toe kept its downward-facing joint until much later, about 2.2 million years ago. So, it seems like early feet might have still kept some grasping ability while people were adapting to walking on two legs. The fully bipedal adapted big toe evolved relatively recently. But weirdly, our feet didn't leave much of a trace in the fossil record until recently. It's frustrating because understanding how our feet evolved is crucial to unraveling the story of human evolution, especially when it comes to walking on two legs. Our modern human foot evolved separately to suit different needs. The chimpanzee foot is more flexible, suitable for climbing trees, while the human foot is stiffer, perfect for bipedal walking. Speaking of feet, we might as well talk about the benefits of walking barefoot. It can actually bring us closer to our natural walking pattern, or our gait. That's a good thing, because it allows our body to move the way it's meant to. Shoes can make you feel like you are walking on clouds, but they can sometimes hinder certain muscle groups from doing their job and strengthening our bodies. But when you go barefoot, for starters, you have better control over how your foot lands on the ground. This helps with balance, body awareness, and even pain relief. Plus, it can improve your foot mechanics, which can positively affect your hips, knees, and core. It keeps your foot and ankle joints flexible and strong, thanks to the proper range of motion and muscle stability. And let's not forget about those uncomfortable shoes that don't fit right. Walking barefoot can relieve issues like bunions or hammer toes caused by improper footwear. Have I mentioned stronger leg muscles? Yep. Going barefoot can give your legs a nice workout, which is excellent for supporting your lower back. So, kick off those shoes and let your feet breathe the next time you find yourself on soft grass or sandy shores. Your body will thank you for it. Not just our feet have evolved over time. Our ancestors had bigger brains too. It means our brains have shrunk. Researchers looked at cranial fossils and discovered that our brains started downsizing about 3,000 years ago. Agriculture took the stage around 10,000 to 5,000 years ago, and civilizations sprouted like mushrooms after a rainstorm. There were sprawling cities, architectural wonders, and even some fancy writing thrown into the mix. The connection between brain size and IQ isn't as straightforward as it seems. Many critters rock brains that make ours look dumb. A massive study with thousands of brain scans and IQ tests revealed that brain size and IQ are like two friends at a party. Sometimes they dance together, and sometimes they go solo, with no strict correlation. It turns out some ant societies are like a mirror to our own, complete with their own version of farming and teamwork. And ants with bigger societies have bigger brains, except when they get into the whole farming gig. But smaller brains might be a cooler choice when teamwork gets super complex. Maybe the invention of writing around 2,000 years ago also played its role. It's like the ultimate external brain. You write stuff down and boom, you have ideas at your fingertips. It's like your brain is outsourcing its memory power. Here is a recent thing you might want to consider, especially if you are a gamer. Some streamers have made an unexpected discovery after spending countless hours wearing headphones. There's a headphone-shaped groove on top of their heads. Let's bring in science before we all start imagining our skulls reshaping like Play-Doh. It's highly unlikely that headphones are engaged in skull remodeling. According to experts, giving a human skull a makeover takes 297 pounds of pressure. So, what's really happening here? The headset is just giving a friendly nudge to our softer bits and pieces, causing a temporary dent that can be smoothed away. Another thing is about your phone holding style. Do you use your pinky to prop up the weight of your device, forming a sort of locked-in position? Ever wondered if this way of gripping might be causing some issues to your hand's well-being? Now, as smartphones keep getting bigger and better, a funny thing is happening. More and more people start noticing this smartphone pinky issue. You might have noticed a tiny groove forming on your pinky from being a loyal phone holder. Let's set the record straight once and for all. Holding your phone this way for long periods can actually bring some trouble. A common issue here is a trigger finger. Basically, bending your small finger to cradle the phone can cause it to get stuck in a flexed position, especially if you've got a trigger finger lurking beneath the surface. It's like a tiny finger traffic jam. Treatment often involves injections or minor procedures to release the tendon tangles. Your wrist might also decide to join the hand-hurting parade. This one causes numbness and tingling in your thumb and other digits. Plus, when your elbow is flexed, like when you're holding your phone to your ear, it can put pressure on the ulnar nerve, leading again to numbness and tingling in your ring and little fingers. Interestingly, apart from a tiny muscle called the arrector-pili, our fingers don't have muscles. So how in the world do we wiggle them? The muscles in our forearms are like puppeteers pulling the strings behind the scenes. These muscle maestros initiate finger movements, and here's where the real magic happens. Those movements are like secret messages zipping down to our fingers through tendons. Think of tendons as those trusty messengers delivering commands straight to our fingertips. How's that for finger wizardry? Whoa, there could have been more human species throughout history than we used to think. In one place in East China, Hualongdong, scientists found the remains of a human who lived around 300,000 years ago. They found a jawbone and parts of the skull. They carefully studied these bones to compare them with the bones of other ancient and modern humans. The remains themselves weren't that unusual. We know our human family is really diverse and has been around for millions of years. You know our ancient relative called Australopithecus, right? These fellas lived in different parts of Africa, and they were known for walking on two legs, just like modern humans. But their brains and some other parts of their bodies made them more similar to apes. Their teeth are a good example of how they were like a mix of apes and modern humans. Their canine teeth were smaller than those of apes, but their back teeth were still larger than ours. There were different types of them. You can recognize some Paranthropus because of their big jaws and teeth. One of the most famous fossils of Australopithecus is Lucy, a lady that's about 3.2 million years old. She was found in Ethiopia. So, we know that our family got pretty big from that point, or probably even before it. But it's always great to welcome some new members, which seemed to be the case with this new discovery. Some parts of these bones look similar to the bones of ancient humans, while other parts look more like the bones modern humans have. For example, the person whose bones they found didn't have a real chin. That means we can't put it in any of the groups we know of, like Neanderthals, or maybe even Homo sapiens. So, might we be missing a branch from the human family tree, or an important step in our evolution? What we're looking at here could be some mix between the creatures that became modern humans like us, and the ones that turned into what we today know as Denisovans. It takes time to figure it all out, though. We hadn't known much about Denisovans either, until we found some of their bones in a cave in the mountains. These bones are really rare, and we only had a few pieces to analyze, but their genes told us a lot more about their past than their fossils. Different kinds of humans lived on this planet, but through time, they spread around. One group started living in Africa. Those are our kind, Homo sapiens. Another group went to Europe. That's how we got Neanderthals. But some of these ancient human groups moved all the way to Asia. That's where we can trace a new interesting kind, Denisovans. It seems they're cousins to both modern humans and Neanderthals. The three species actually shared a common ancestor about 765,000 years ago. It's still not clear why Neanderthals and Denisovans took different paths, but one theory says that it was mostly because the Arctic ice sheet expanded southward all the way to the Black Sea, cutting off Europe from Asia. Life, or better yet, the planet, kept them separated for a very long time. Plus, they kept changing places where they lived all the time, always looking for something better, like every other human species before and after them. But this didn't last forever. Scientists found genes from two groups of Denisovans, one in mainland Asia and the other in a place called Melanesia. So not only did they have different groups within their populations, but it also seems that after thousands and thousands of years of developing independently, the members of these three populations, Neanderthal, Denisovans, and modern humans, somehow met again and spread all across the land. 5% of the Denisovan genome lives not in the area where scientists found their bones, but in people that live thousands of miles away in Southeast Asia, for instance, in Papua New Guinea. But scientists believe that the cave where they found the remains of Denisovans might be as far north as they had lived. It would have been way too cold for them to survive if they had gone further north. From there, they traveled as far south as Indonesia. This was possible because, during their time, sea levels were lower than today. So Indonesia was connected to mainland Asia. But they probably didn't make it to Australia since it was still separated by water. These three groups mixed together too. Scientists have found a bone of a girl who had a Neanderthal mom and a Denisovan dad. It's the only first-generation hybrid human we've discovered. She even got a cool nickname, Denny. One of the mysteries about Denisovans is how they disappeared. Maybe they mixed so much with other humans that they just blended in. Or it's possible that modern humans' ancestors were stronger, had better tools, or even brought some diseases that didn't affect them, but affect Denisovans. Climate and where they lived might have also played a role. Denisovans lived in a wide range of environments, from cold parts of Asia to tropical Indonesia. Climate changes and the challenges of different habitats might have been really difficult to survive. But it's hard to draw strict lines in our family tree. We're still relatively new at learning about it anyway. Who knows how many new members we are about to discover? Half a century ago, a team of scientists had an idea that a collection of fossils they found at the Great Rift Valley in Tanzania were actually the remains of some new human species. Yup, that was the time when we welcomed Homo habilis into the family. It was a big discovery at that time since people mostly believed that the story of our evolution had been really simple. First, there were Australopiths that looked like apes. After them, there was Homo erectus, the upright man. They most likely lived in Africa around 2 million years ago, but also expanded really quickly across Eurasia. It was the first human species that we know about to have traveled such long distances to find a better place for life. They looked and behaved like humans. Plus, they were probably the first of our ancient ancestors who learned how to deal with fire. Maybe they were the first to cook food as well, and that's what we're definitely thankful for. Cooking food was an innovation that made the human diet more nutritive, and we could grow bigger and smarter brains. So, yeah, Homo habilis made things more complicated. They could walk on 2 legs, but they could also be better at climbing trees than walking on the ground like us. Plus, their brains were smaller than what a human should probably have. At first, it seemed these fossils could be from a completely different side of the family, related to other creatures, Australopithecus africanus, that looked like apes. But more and more digging showed that even though its jaws and teeth were similar, Homo habilis was still bigger and a bit different. The name means handy man, because they were probably able to make and use simple tools. Searching for more fossils in Africa wasn't easy because a team of researchers had to deal with wild animals and tough conditions all the time. But eventually, they managed to find some teeth and a strange skull that was, again, something different from the ancestors we knew about. The teeth were really big, so this new fella got the nickname of Nutcracker Man. For a long time, everyone believed this kind had evolved to eat hard foods. But the fossil teeth didn't show much damage, so they might have been eating food that was softer than we thought. This finding might help us understand how our teeth have been evolving through time, too. And right there, in the same layers of soil where Nutcracker Man was lying, they found ancient stone tools. At first they thought those had belonged to Nutcracker, but as they kept digging, they found more fossils that didn't match Nutcracker Man. It means that someone else must be the real tool maker. But that's another story for another time.
With more than 8 billion people in the world today, it's hard to imagine there was a time when there were so few human beings that they almost went extinct. It happened about 900,000 years ago when our ancient ancestors faced a crisis. Recent studies tell us there were only about 1,280 of them left, which is an incredibly small number. It's like just one village or a very, very small town left alone on the whole planet. The human race got into a population bottleneck where almost 98% of people disappeared, and things were tough for them for more than 100,000 years. We don't completely understand why this happened, but it was likely the result of tremendous changes in Earth's climate. It was a time when periods of cold weather lasted longer, the sea was colder, and there were more glaciers. Monsoons were immensely powerful, and yet there was less rain. These changes had an impact on wildlife species in Africa and Eurasia, and many plants and animals that were food sources for people disappeared. But at some point, our ancestors showed their strength and managed to bounce back despite tough times. The numbers started to go up again, because people learned how to handle fire better. Plus, temperatures got warmer too. But what would the world look like if nature had defeated us and it all had really stopped for humanity back then? Let's take a trip to some parallel dimension where it really happened. In that universe, there wouldn't be empires, pyramids, and impressive achievements that some old civilizations left us. No neighborhoods, cities, your favorite park, or that bench where you like to sit and drink your coffee. No coffee. Ouch, that hurts. No pools, adventure parks, and no rush at the beaches. No creature would be able to go to another continent separated by the ocean. There would be no ships or planes that could carry it. Animals would have to wait for tectonic plates to move again to visit new territories. Wow, you've just realized how incredibly silent the world is. All because nature almost never produces as much noise as humans do. Our buildings are noisy, together with cars, motorcycles, and all other vehicles. If you live somewhere by the airport, you know how much noises planes can make too. And here, no one's phone's ringing. You don't hear music coming from bars or gyms. Wow, look how incredibly blue the sky is. You've never seen a sky like that in your world. The rain and wind scrub the surface of our planet clean, although there's not much work to be done since there's no dust and smog humans produce. I mean, there is dust, but a different kind, one that nature creates. We don't really notice it since we have so many heaters and air conditioning systems that blow air and all that dust around. The only drinking water you see is in lakes and rivers, and lots of different animals get together in these areas. It takes a while to get used to it. Wherever you go, there are wild animals passing by. There are no dogs, cats, or other pets you're used to. There's no electricity either. In case you've brought your phone, take pictures as fast as possible because you won't be able to charge your gadget when it runs out of battery. There's no internet though, so you'll be the only one who will see the photos. It's so weird to see grass so tall and wild. No one mows it, so it's hard to walk, especially considering there are no roads. And you don't have a scythe or any other tool that could help you clear your way, because human civilization hasn't reached that level of progress. Wow, there are plants you've never seen before. Every time a tree drops a seed, something new might grow. And there are no humans to select which plants they like and which they don't. You suddenly feel nostalgic, thinking of carrots, broccoli, potatoes, and all other vegetables people once started growing on their farms. You can hear tons of bugs buzzing around. We usually do everything to get rid of them, and now, without humans, you get to see how annoying they really are. Hey, the sun is going down. Without electric lights, all creatures just follow the rhythm of nature. So, if you're up for a late-night walk, wait for the moon and stars to lighten your path. But be aware of night predators. You may face creatures that didn't survive in the world where humans rule. Fire. Luckily, there's a river nearby, so you jump into the water to get to the other side. Fires happen more frequently in the world without humans. For instance, lightning can strike a tree or set a brush on fire. No one is there to put the flames out, so fires just keep spreading until at some point they burn themselves out. It's hard to see the world like this, but it's even harder to accept that Earth is fine without us. Just like it's doing well without dinosaurs, megalodons, woolly mammoths, dodos, and other ancient creatures that went extinct. Back to the research. Some scientists don't think our ancient ancestors were really that close to extinction. To get these results, researchers used FitCool, a special tool that helps study changes in ancient human populations by looking at the genetic information of modern people. They examined DNA from over 3,000 individuals in Africa and other places for this study. Some believe that the actual population numbers might have been bigger. The method used focuses on a small group of breeding individuals and may not exactly represent the whole population. There may be many archaeological sites in Eurasia and Africa that date back to the time when this population decline might have happened, so it may have affected just some groups of people in certain areas. Either way, not only wasn't it the end, but it was a new beginning. Two ancestral chromosomes combined to create a structure known as chromosome 2 in modern humans. This might have been the start of a new species, because there was a split between our ancestors and other ancient humans, such as Neanderthals and Denisovans, our ancient cousins. Some evidence tells us this idea is plausible because our common ancestor lived about 500,000 to 700,000 years ago. Well, humans did survive all those devastating moments in history, but scientists believe that the extinction of our species is a matter of when, not if. Our fields will overgrow, cities will end up in ruins, and bridges will fail. Nature quickly reclaims the landscape where humans don't go. Check out how these roots and trees have taken over the temple in Cambodia. Roman ruins still defy time for over 1,500 years now. Some of the buildings and things we create in the modern world will do it too. Nature will break everything down at some point, and if humans were to go extinct, who would replace us? It took 200 million years for our kind to evolve from the first mammals. Who can repeat this entire process again? The last common ancestor of chimps and humans lived 8 million years ago. Knowing this, it seems possible that if Homo sapiens went extinct, a new species capable of using technologies would evolve from chimps. But hold on. There's something called the Fermi paradox. Even though there are hundreds of millions of rocky planets that could host life in our galaxy, we don't see any evidence of its existence. Our galaxy is 13.5 billion years old, so you can't say life hasn't had time to develop. One possible explanation is that certain crucial steps in the evolution of intelligent life are so rare they hardly ever happen. So, Earth would get along fine without us. The only ones who would care are us. And right now, we need to care a lot. Well, you're having an amazing sandwich when suddenly you bite down and taste something bitter and tangy. Ew. You inspect your food and don't see anything unusual. But throughout the day, when you go drink some water or grab a snack, something's still off on your taste buds. You get it checked out, and it turns out you have a gland that's excreting some strange substance. After patiently waiting for the results, you find out you're producing venom like a rattlesnake. Your eyes pop open and you storm out of the clinic like crazy. Truth is, scientists claim it's possible for humans to produce venom. Hey, if you've been on some social media lately, you might say it's already happening. In fact, there are mammals out there that are part of the venomous club, like the platypus, slow loris, and vampire bats. A platypus has venom on short spurs near its hind legs that can be pretty painful for humans and needs extensive care to get rid of. Even though they're cute, they're not to be played with. A slow loris is the only primate to be venomous and gets the award for being the cutest too. They have small sacs underneath their limbs which they lick before biting their adversary. They're also endangered and should not be kept as pets, obviously. It's common knowledge vampire bats like the taste of blood, but underneath their sharp teeth and scary looks, they have some venom brewing up. It's not exactly painful like the platypuses or slow lorises, but it acts as a chemical to keep the blood flowing when feeding on their prey. Now don't worry, these winged venomous creatures don't usually feed on humans, but that doesn't mean we're entirely safe. While snakes develop their venom for catching prey, venomous mammals use theirs for defense. Humans develop tools and shelter instead to protect themselves from any kind of threat, which is why evolution didn't give us fangs for biting or a shell to hide in. Venom even differs from species to species. A desert snake's venom specializes in slowing down prey, since they have the entire desert ground to track it. But snakes that live in rocky mountains or tough terrains have venom that's potent enough to give a good knock to the receiver. There's a study showing that salivary glands, found in almost all creatures, including humans, might determine if we could, one day, have venom glands. And saliva is the common thing that connects the dots. You're running down the street trying to make sense of everything. You're sweating and the saliva is getting thick in your mouth. But you can even taste the bitter cocktail in your mouth, and it's not something you ate. You find the closest stand and buy some water to drown it out. No use. After calming down, you go back to the clinic and they try to explain what happened. Venom systems have evolved many times in history. Scientists studied a group of thousands of genes that can be found in animals with venom glands. And what they learned was those could develop in other animals as well. You can actually find similar toxin components in centipedes and snakes. The venom itself may have a different effect, though. It all comes down to what their glands excrete, special kinds of protein. So, by coming up with this protein, any creature with a salivary gland can produce venom. And it happens that you've become the only human on Earth with venom glands, which means you can't do anything publicly that involves saliva. You freak out once more and run back to where you'd thrown out that bottle of water. After wildly rummaging for it in a trash can, you finally find it and let out a sigh of relief. People around are staring and snapping pictures. You call your family and tell them the news, but they laugh it off and think you're pranking them. The doctor at the clinic calls you back to study you further, and you agree. Tree frogs seem like peaceful creatures, but some species are actually poisonous. The more colorful they are, the more you should avoid them. Venomous animals are those that use their toxins to hunt their prey, but poisonous animals use them for self-defense so that nothing touches or eats them. Poison dart frogs in South America are among the most poisonous animals in the world. And whatever you do, never go for the gold. The golden poison dart frog is one of the biggest threats out there. Look at its tiny yellow head. They've been around for centuries, scaring the locals around with their amazing colorful patterns and tiny little hops. Water hemlock seems like your everyday plant growing on the roadside, but don't even think of putting a strand of it between your teeth. Water hemlock's been deemed the most violently toxic plant in North America. Ironically, it's also part of the carrot family. Nightshades are quite famous and even made their way in one of Shakespeare's plays. They may look like tasty little berries you'd find in a fruit stand, but they're far from that. Even touching them can be pretty nasty if you're not careful. It's unlikely that we'll develop venom anytime soon, or at all, for that matter. Evolution has proven that animals can even stop producing venom since it relies on the special proteins from nature rather than genes. There are species of sea snakes that have venom glands but can't use them anymore. Their diet switched from fish to eggs, which don't need any venom to hunt them down. We can look at our own bodies and witness evolution in the process. I mean, not literally right now, that would take forever. But our ancestors used to live in situations where they could turn from predator to prey in a second. Living in the open savanna had its disadvantages since you were like an open buffet to anything that wanted a snack. We have tiny muscles around our ears that are so weak that only few people are able to move them. They're there to show we had the ability to turn our ears in the direction of a sound source, just like a rabbit in a field. This helped us to both escape danger and find hiding prey. Almost all mammals have whiskers. It's so common that you even named your cat Whiskers. Only platypuses, anteaters, and humans don't have any. Whiskers are hypersensitive antennae that can help animals with their surroundings and in tough environments. Think of this as an X-ray vision for mammals, minus the cool sci-fi tech. If an animal was in a pitch-dark environment and couldn't hear anything, then whiskers could navigate them out of there. Humans do have tiny muscles on our upper lips where whiskers would be, but we grew out of that. Some evolutionary traits are out of our control, like the ability to have goosebumps when cold or listening to an amazing song. The average human lost their thick coat of fur used for insulation. The tiny muscles under our skin contract when we're exposed to certain situations, and it's most likely our hairy ancestors used it to become warmer. Nobody loves trips to the dentist, but over time, we might lose at least one reason to do it – wisdom teeth. Sadly, they don't make you any wiser, but rather bring you discomfort and even sleepless nights. Ancient humans didn't have dentists at all, so nature took care of that for them. With time, molars would wear out and crumble from all the chewing, so the third molars, aka wisdom teeth, grew just in time to become a replacement for the old and useless ones. Since we all evolved from vertebrate creatures, or animals with spines, both humans and apes, like chimps and gorillas, have tailbones at the bottom of their spinal columns. Dogs have it for wagging their tails, monkeys use it as an extra arm when climbing trees, and cheetahs need it when speeding and making quick shifting turns hunting down prey. According to scientists, no early member of the human species had a tail, especially since we started walking upright. The future of human evolution will be joint with technology, according to some opinions. We may be able to merge our brains with supercomputers and even a cloud type of storage. Hey, my brain has been cloudy for years already. Technology may even increase our lifespans and improve mobility, making walking less and less important compared to what we have today.